So this question is also about vector addition and subtraction. So let's go to the question. So there are two swimmers that leave point A on one bank of the river to reach point B lying right across on the other bank. One of them crosses the river along the straight line AB while the other swims at right angles to the stream. Okay, I think it will be better if I start drawing. So basically you have this two sides of the river. This point A, this point B. So the first swimmer does is directly crosses through AB. So obviously due to the velocity, like let's say the river flow is in this direction. So obviously intuitively the swimmer has to start swimming in this direction, so that because of the river velocity the resultant velocity vector is along the direction of AB. This is for the case of the first swimmer, right? And for the case of the second swimmer, what happens is it also starts from A, but it starts swimming at right angles, but due to the river velocity, obviously again what happens is starts swimming like this, river velocity this way, so it goes in some oblique direction, reaches some point C, let's say, and from there it walks the distance that has been carried away by the stream to get to the point B. Okay, so basically it has been carried away by the stream to point C, then it now starts walking back where to point B. Now what must be the velocity u of his walking? So that's what walking speed is, what we want from C to B if both swimmers reach the destination simultaneously. Okay, time taken both swimmers is the same. Stream velocity v0 is given, and the velocity of each swimmer with respect to water is basically v dash is given. All right, so now let's say we consider swimmer 1. All right, swimmer 1. Swimmer 1, so the resultant direction is from A to B, but it tries to swim in this direction initially, in some oblique direction, and with a velocity magnitude of v dash. Just write the magnitude here. And due to the river velocity of magnitude v0, the resultant, let's call it v1, so that's the first swimmer v1, is in the direction of A to B. All right, now so basically what is happening is so v1 v c is basically the addition of these two vectors. Okay, so if you think intuitively, if we think, so yeah, we can think it this way. So this is basically vector addition, but if we think about the magnitudes, this is a right angle triangle, and so from the Pythagorean theorem we have v1 equal to root over v dash square minus v0 square. So that's the magnitude. Got it. Now we go for swimmer 2. All right, okay, before jumping on to that, let's consider this distance to be d for now. Okay, now for swimmer 2, so swimmer 2 starts swimming in this direction with velocity magnitude of again v dash, but what happens is, okay, it is carried on forward by the stream with velocity magnitude v0. This is a resultant velocity magnitude v2. This is the second swimmer. So again, by Pythagorean theorem, there is a right angle triangle, this is hypotenuse, so v2 is equal to over v dash square plus v0 square. All right, now here is an interesting thing. We mentioned this distance is d. Okay, now we know that basically if we consider this triangle ABC, drawing it again here, right, A B. See, this is a right angle triangle, right? This AB is D, and let's say this angle is phi. All right. If this angle is phi, it's basically the direction of V2, which is the direction in which second swimmer swims, which is AC, with the horizontal, which is BC. This is nothing but the same. This is nothing but the same phi. All right. Now, so what we have from here is, we can say tan phi is equal to V dash V naught. So this is something that we will need. Okay. All right. Now, okay. So basically, this is just the. This is the first part of the journey of the second swimmer. Now it also has to walk on the land. All right. So let's say on the land the speed is u. Now we have got all the speeds. Once again, for swimmer 1, the time taken, which is t, is equal to, basically distance is t, right? So if we see, the distance is d from A to B divided by v1, which is root over v dash square minus v naught. Okay, I think it's completeness I'll write it as v1, which will basically become d by root over v dash square minus v naught square. Alright, now let's consider swimmer 2 again. So let's say for swimmer 2, TA is the time in water and TB is the time in land. So TA would essentially be, the distance is the oblique, since L divided by V2 is nothing but L by, we already know what is V2, root over, so I'll just label it as 1, this as 2, this as 3. So this basically came from 1, right? Now this is coming from 2, v dash square plus naught square. This is from 2. Okay, so now again, if we go back to the triangle, this is L and this I'm calling it as X. So now in terms of phi, L would essentially become, this will become d cosec phi, right? Because sin phi is d by L, and X become d cot phi, because tan phi is d by X. So these are just simple relations from trigonometry. So L is d cosec phi. So just write it as d cosec phi by root over square plus v naught square. We'll substitute cosec phi in terms of tan phi later on. So yeah, all right. This is TA. Now TB. TB is basically the time on land, which is x, by u, which we need to find out, that is the walking speed. X, as we already know, is d cot phi. So x is d cot phi divided by u. Okay, now we know that t is equal to ta plus tb from these three values that we got. I think I should have labeled these two also. So 1 2 3, let's call it 4, let's call it 5. So basically this is from 4, this is from 5. A lot of equation numbers, nothing to be worried about, that's just for completeness. This is, let's say, 6, this is, let's say, 7, and this is, let's say, 8. So t equal to ta plus tb from 6, 7 and 8 basically. 6 is gives you t d by root over v dash square, root over v dash square minus v naught square. What is ta? Ta is t cosecant phi divided by root over v dash square plus v naught square. So what is tb? D cot phi divided by u. So now this is from equations 6, 7, 8. 6, 7, 8. Now as we know here, d and d cancel out. Alright, and we already know that tan phi from 3 is v dash by v naught, right? This means 1 by root over v dash square minus v naught square is equal. Cosecant is basically cosecant square minus cot square, cosecant square phi minus cot square phi equal to 1. So root over 1 plus cot square phi. Cot square phi is intuitively 1 by tan square phi, not intuitively, according to trigonometry. So yeah, so it basically becomes 1 plus reverse of this v dash v naught by v dash, v naught by v dash whole square. This is your cosecant phi divided by root over v dash square plus v naught square. Okay, plus cot phi is just the reverse of tan phi, v naught by v dash, and u is in the denominator. This all came from, apologies, from 3. Yeah, so from equation 3, the value of cot phi and cosecant phi. Now there's a lot of square roots and all here. What we need to find out is u. Alright, so we'll just gather u on one side, v naught by v dash u. So that is equal to 1 by root over v dash square minus v naught square minus root over, so I'll just multiply within the square root only. I'll try to solve it. So it becomes v dash square plus v naught square. Okay, this is v dash square and v dash square into v dash square plus v naught square. Okay, then this cancel out, so simply becomes v naught by v dash u 1 by root over v dash square minus v naught square minus 1 by v dash. So u, this is should be simple, I guess now. So u, we want to reverse the thing. I guess what we can do is, the thing we'll do is, we'll try to v naught by v dash u, we'll try to take out v dash. So v dash, this becomes minus 1, I mean 1 by v dash, and this becomes 1 by root over v naught by v dash whole square. Okay, v dash gets cancelled, which means u is equal to v naught divided by, we can write it as 1 minus v naught square by v dash square whole power minus half, right? This goes in the denominator, and obviously this minus 1. So v naught divided by 1 minus v naught square by v dash square whole power minus half, because yeah, it's a square root and it goes in the numerator, so minus half minus 1. So this is basically the required value. So there you have it. This is the walking speed. So you can substitute the values of v naught and v dash in order to find the actual value. Thank you.